be talking about mixed number coefficients. So, as a reminder, we're solving problems that have variables. We call these algebraic equations. You know that we need to solve because they have equal signs. So we're not just going to simplify. We're going to get down and find an answer. Our letter is going to equal a number. That's our ultimate goal in these, to get down to letter equals number. In our problems today, we're going to have our coefficients. The coefficient is the number multiplied by the variable. Here's a coefficient, here's a coefficient, here's a coefficient. We're going to have our coefficient that's a fraction, or that's a mixed number. And we're going to look at how to solve those. I want to teach you two ways today. Way one, if you have a fraction or a mixed number coefficient, and you just have one, so this way works best when you just see one fraction, but it'll work when there's two. Multiply by the reciprocal. Remember, the reciprocal of a fraction is the fraction that it multiplies by to equal 1. So the reciprocal of 2/3 is 3/2. The reciprocal of 1/2 would be 2/1. Let's try it here. I have 4/5 times x equals 7. I want to solve for x. Usually what I would do is I would divide by 4/5 on both sides. When we go to solve a division problem though, 7 divided by 4/5, to solve a division problem with fractions, I would need to change to multiplication and take the reciprocal. I can save myself a step by multiplying by the reciprocal on both sides. So if I don't want to divide both sides by 4/5, I can multiply both sides by the reciprocal. Here's what that looks like. Times 5/4 times 5/4. 5/4 times 4/5 equals 1. 1 times x is just x. 7 times 5/4. We don't want to multiply a whole number times a fraction. We want to make the whole number look like a fraction, so we're able to multiply better. We're going to write it as 7/1 times 5/4. Now I can multiply. 7 times 5 is 35. 1 times 4 is 4. X equals 35/4. I can reduce this number now, put it in simplest form. Ask myself, how many 4s can I get out of 35? That'll be my whole number. Whatever's left over would be my fraction. So 4 times 8 would be 32. That would leave me 3 left over. So we're solving with fractional coefficients by multiplying by the reciprocal. Let's try that with another problem here. I've got 2 more problems I want to do. Let's try that with another problem. 3 1/3 x times 5. If you have a mixed number, change it into an improper fraction before you do this. Don't try to do it with the mixed number. To change to an improper fraction, we multiply the denominator times the whole number, and then add the numerator. 3 times 3 is 9, plus 1 is 10. 10/3 x is 5. Now I have my fractional coefficient. Multiply both sides by the reciprocal. Times 10/3. The reciprocal would be 3/10. If I do that to this side, I do it to the other as well. Times 3/10. 3 times 10 is 30. 3 times 10 is 30. 30/30 is just 1. 1x. I've essentially canceled out my fraction. 5 times 3/10. Let's write our 5 so it looks like a fraction. 5 whole things can be written as 5/1 times 3/10. 5 times 3 is 15. 1 times 10 is 10. X is 15/10. Now, it's tempting to write this as a decimal. 15/10 can be written as 0.15. Because I have it as a fraction though, I'm going to reduce it so it looks like a fraction. If I have 15, how many 10s can I have? I can have 1 10 with 5/10 left over. Reduce 5/10 again, both will divide by 5. I'm left with 1 and 1/2. All right, let's try this problem a third time. I have a negative coefficient, fractional coefficient, that's okay. Follow the same system. multiply both sides by the reciprocal. The reciprocal of negative 2/3 is going to be negative 3/2. So times, oops, I can't quite squish it in here, I'll squish it down here. Times negative 3/2 times negative 3/2. Number, reciprocal. Negative 3 times negative 2 is positive 6. 3 times 2 is 6. I end up with 6/6, which is 1. A negative times negative is positive. It's a positive 1, which is just x. 1x. The 1 is implied. If you like, you can write the 1. That's okay. It's not wrong. But really, there's just 1x. Now I can multiply my numbers. This is already a fraction, so in some ways this is easier. I can just multiply across. I don't have to have a whole number that I put over 1. 4 times 3 is 12. 5 times 2 is 10. A positive times a negative is negative. Let's reduce this. If I have 12, how many groups of 10 can I make? I can make 1 with 2 left over, 2 10s. 2 and 10 will both divide by 2, so I can reduce that further. X is negative 1 and 1/5. Okay, so this is way 1, multiplied by the reciprocal. I want to show you one other way, and this uses your least common denominator. Now, when we're multiplying and dividing fractions, we don't usually need a least common denominator. The least common denominator is when we're adding and subtracting. And that's when we want to make sure that we have the same denominator. You can use least common denominator to help you solve a problem with fractions so you don't even see the fractions. Let me show you what that looks like. Okay, so I have 2 denominators. I have a 5 and a 4. Let's find our least common denominator, and I'll show you how this works. 5 and 4, so start counting by 5s. 5, 10, 15, 20, 25. Start counting by 4s. 4, 8, 12, 16, 20. The first number on both lists is 20, so my least common denominator will be 20. Here's what you can do. Multiply that least common denominator times everything on both sides. So 20 times